Now hopefully this is a review. We're going to add the other two pieces, which is left, right, up, down. So cosine x plus 2, how is that different than cosine of x? Oh, you must have had an amazing Math 12 teacher. And then what about the next one? Down 3, that's right. Okay. So vertical translations, we call these the vertical displacement, which I sort of talked about earlier, the center line. Personally, I like calling it the center line because that reminds me visually of what I'm talking about. Okay, so how can we compare sine of x plus 2? Good. You guys remembered. And the next one? Yeah, right by pi. So in trig, we're going to see those units a lot show up because those are some of the points on the unit circle that we're moving over by, like pi, pi over 2, pi over 4. What about the next one?
Horizontal stretch factor by 1 over 3 and right 9 pi. Right.
Ooh, good. So remember the first thing, it's still the same rules that apply. Factor it first, and then it'll be easier to see. Okay. So when we do horizontal translations, I actually made a mistake. I guess something in my brain heard the word horizontal and put it in the wrong spot. This is actually what we call a phase shift, not the horizontal stretch. So my apologies there. When we move it left and right, that is the phase shift. Okay, so now that we're about to move the graph, it's important to remember where you normally start. So my advice is start by graphing two lines. Plot the center, and this is the horizontal, and plot a starting line. It'll be vertical. Oops, that should be line, not ling. So let me show you what that would look like then before we get started on the next one. Okay, the center line here is -1, so that's what I'm going to do. I'll drop down to -1, and I'm just going to go like this so that I can see where the center is. And then I'm going to go left by pi. So here's left by pi. And that's what I call my starting point, because the graph normally starts right here, but it's been backed up by pi. So now I'm going to make that little imaginary marker so that I know where my graph starts. Okay, this one's moved left by pi. Okay, now I can talk about the same pattern we have before, which is sine starts right there on the center line. It goes up to the maximum, back to the center, down to the minimum, center, maximum, center, minimum. Goes through the same pattern, but now that I have a starting point, I know where I'm going to be moving from. Okay. Period here is 2 pi, so that means my key points are going to be every pi over 2. So I'm going to go up to here, back down to there. Every pi over 2, I find a new key point. One more time. There we go. Now, again, if you were to pick the starting point we had before, it's harder to work with because you'd have to realize you're going down, and that doesn't usually make sense to people. It's easier to think about where the graph moved and then just start at the new place you moved to. Okay? So you try the next one. Start with a center line. Start with a starting line. That's confusing. Start with a center line and then plot your vertical line too. Okay, so I'm just going to put my graph up here. If you're not done yet, you can just catch up. But here's where I would mark my center line and my starting point. And normally the cosine is going to start one above its center. So normally the cosine will start there. Okay? So now I'm ready to talk about where my key points are. Period is 2 pi. So my key points are going to be every pi over 2. So here's the next place I'll run into a key point. Then at the minimum, back up to the center line. And then I'll run out of space on that side of the graph. I can keep working this pattern backwards too, right? So from here I'm going to go down to the center, then to the minimum, and back to the center. And then I'll be at maximum and center line. Oops. Okay, so it's roughly going to look like that black line once you've shifted the graph vertically and horizontally. All right, so this is it. It doesn't go any further than this. This is putting your pieces together. So I'll walk you through the process, and then I'll let you guys try one. What I'm going to do to start here is put my center line in, just like I said before. Start with a center line. And I also want to know where the graph is shifted. So there's my starting point. Okay. This graph has a period of 2 pi over 1/2, which is 4 pi. You can also think about it as 2 pi, and it has a horizontal stretch factor of 2. So now I have a period of 4 pi. My key points are going to be every 4 pi divided by 4. So every pi units, I'll find a key point. So here's where they are then. My starting point, there'll be a key point. There'll be a key point here. There'll be a key point there. I'll have key points every pi units. So I can mark, now I know where I'm looking for the key points. Okay. So now let's actually put them on the graph. Cosine starts at the top, which in our case is 2 units higher. Amplitude is 2, so I'm going to go 1, 2 units higher. Then I move down to the middle. And then I'm going to go 2 units lower, 1, 2. Then I'd be back to the middle. So that's how I could go through the key points that are here. And I'll repeat this process backwards. So the next point is falling back to the middle, then down to the bottom, then the middle, then the top. Oops, too high. And then back to the middle. So that would be the graph in this case. So start in the same spot. Put in your center line, look for a starting point. Then you have to figure out where your key points are going to be. So what's the period? How far apart are the key points? Okay, the next one is up for you. I'm just going to remind you, do this. And then start graphing. So don't look up yet if you haven't finished it. I can see some of you are still at work here. Okay, so you should have a center line at -2. You're going to start by shifting it pi over 2 to the left. So that's the vertical and horizontal line that get me started. It's a sine graph, so I know I start right on the center line. So there's where I'm going to start. And my key points are all marked in black here. So period is pi, because there's a horizontal stretch of 1/2. Key points then will be every pi divided by 4. So first one is there. Then I'm going to go up by 4 units this time. So 1, 2, 3, 4 units up. And then back to the center line. Then down 4 units. back to the center line, up 4 units, down 4 units, and I'll just do the pattern the rest of the way to finish off my graph. And it should look something like that. Can I get a sense for how many people are getting the hang of this? Is you have a graph that looks like, oh, awesome. Okay, that is it. We're not, you can handle that. You're golden. That's as bad as it gets when we do trig graphing. Okay, the last thing we'll talk about we haven't added yet is a reflection, right? It's not going to change our process. We just have to change how we think about putting our key points down. So let me walk you through it. We'll do everything just like normal, the way we set it up. So we start with a center line at -1, and oops, a starting line at pi to the left. And I'll keep track of everything like I normally do. My amplitude here is 1. My period is 2 pi divided by 1/2, which is going to make it 4 pi. So that means I have key points every 4 pi divided by 4, which is every pi units. So here's what it's going to look like. Every pi units I run into a key point. Okay. So now I'm ready to go. The problem is, when I do my key points, this is how I normally want to walk through my sine graph. I'll do it in gray just so it shows up lightly. I'm going to say start at the middle, then move up 1, and then back to the middle, down 1. And I'm going to have this picture here, but I've done a reflection, right? Which way does this flip? X-axis or Y-axis? Yeah, it jumps across the Y-axis. So for us, it's going to look like this. Everybody's going to jump across here. So if I jump across, instead of doing it the way I just did, I'm going to go backwards. I'm going to say, okay, you should have been the one that went up, then back to the middle, then back down, like that. See, this point here had to jump across, right? The graph flipped over to there. So the real graph, I'm doing the sine backwards. Instead of going to the right and up 1, I'm going this way. Okay, so this again was where we would have started if we didn't see that reflection, right? As it would have been this way. But because I flipped it, I'm going to go backwards instead. So it takes a little practice to get used to going backwards in your reflection. But I'll get you guys to try this one, which is a different kind of reflection. But again, everything starts the same. It's just before you take that first step and plot your key point, you have to think about how this would have flipped your graph. Okay, so the first thing is to factor that out. And now I'm going to put down my center line, which is at -1. And my starting line, which is here, oops, sorry, which is here, move to the right by pi over 2. And my amplitude, which is 4. My period, which is 2 pi over 2, so it's pi. And then my key points, which are going to show up every pi over 4. So here's where I'll find key points. Every pi over 4, I'll find a key point somewhere along here. Now the starting point for cosine is normally the top. I move 4 units higher, so I'd go 1, 2, 3, 4, and this gray dot is where I normally would start. Is that still the case? No, this has been reflected. It's all the y coordinates are going to be affected, right? It's going to jump everybody. It's an x-axis reflection. So this point here, like all the other ones, is going to be reflected down to the bottom. So I actually going to start at the bottom this time. So it would be 1, 2, 3, 4 points down. That's the actual starting point here, the purple one. Okay. So if you were to do just the general cosine graph, right, it'd be this gray graph, which is incorrect, right? But it gives you a sense of what's happening in the other graph. If I'm down at the bottom, then when I reflect it, I better be up at the top. So the real graph would be like this purple one. Not like this gray one I'll just put a dashed line on. Okay. So if I continue the pattern, I mean, once you get 2 or 3 points there, you can just follow the pattern for the rest of your graph. So it's going to go middle, then up to the top, then back to the middle, down to the bottom. And there's the rest of the graph. So when you have a reflection, you really just think really hard about where that first and second point are going to be, and then you can follow the pattern through the rest of them, right? So look for where how's that reflection going to change this graph? Normally, if you're moving to the right, that means now you're moving to the left when you do your points. If you were moving up, now you're moving down. Okay, so the last thing that we need to be able to do is to figure out what's the equation when we look at the graph. Okay, so let's see from these couple examples if we can do this. So there's some key things that we've got every time we do a graph. And these are what they are. We're looking for the amplitude, the period, the phase shift, and the center line. Once you have those, the rest of it, you don't need any more information. You can come up with an equation for it. So what do you think? If you look at that picture, can anybody figure out one of those things possibly? It could be cosine, it could be sine. Good answer. It says find one of each, so center line is 3. Yeah, you can see that in the picture here. So visually you can see there's a center line there. Well, let's just call it 3. The vertical displacement is 3. Now once you have a center line, you should be able to find something else out in that picture. Oh yeah, period is 2 pi. Yep. Don't need the center line for that one. But now that you can see a center line, you should be able to see something else in that graph. Yeah, the amplitude is 2 because I drop down by 2 and I go up by 2. So the center line, the amplitude is 2. And Jem sort of just dropped this bomb at us, which is absolutely correct. But yes, that width is 2 pi. That's how we knew the period was 2 pi. Okay, so now we have to figure out the phase shift, and it depends which graph we're talking about. So let's think about this from the point of view of cosine. Does anybody see where the cosine starts when they look up at this picture? It's this spot here is normally where we think of it starting, right? And then it dips down. It makes that valley. So this is normally where we would picture the cosine starting. How much did it get moved then? It normally starts right here at 0. So how much has it been moved to the left? Yeah, so it's pi to the left in terms of cosine. And then what about sine? Does anybody see where the sine graph starts? So sine graph normally starts on the center and starts rising. Sine graph normally looks like this, right? Up. So this is the center and rising. That's the point I'm talking about. Where does sine start in this picture? At the center line and rising. Then the pattern would continue, and we'd think that like a sine graph. Okay. So in this case then, what's the phase shift? How much has the sine graph been moved over? Yeah, pi over 2 to the right. So I can give you a couple of equations now. I have 2 times the cosine. Let's see here. Now the only thing that's not appearing in my equation yet is the period. We didn't say how we were going to account for the period. And it's the horizontal stretch factor that messes around with it. So what we said was if you have like y equals the sine of bx, then the period would be 2 pi over b, right? So we want to go the other way around then, is we want to know if the period is 2 pi, what's that value for b? Yeah. So in this case, the horizontal stretch factor is a 1. You don't need to write it in, but that's how we find it. Yes?
Don't we see reflection? So we don't consider reflection at all?
I'm not exactly sure what you're...
So let's say maybe the graph got reflected.
Yeah. Yeah, you can do that. It's just that's usually a layer of complexity that on our first example people don't want to see just yet. But what Steve's getting at is you could look at this point right here and maybe you say, that is a sine graph. It just so happens it's the negative sign because it's been flipped. You can do that if your brain works like that. That's fine. Same thing right here. You could consider this a cosine graph. Do you know what spot that would be on a cosine graph? Like what's happened to it? Yeah, it's been flipped as well. This is a negative cos, right? Because it's not at the top, it's down at the bottom. So we'll talk more about versatility when we get into applications, but for today, you just need an equation. So a cosine and a sine graph. So you use this picture here. See if you can reconstruct an equation. If you want to put negatives in there, go for it. But just see if you can reconstruct one for sine and one for cosine. So I want to give you some tips to finding these things here. So you might have already figured it out. But one thing we already talked about was you can find the amplitude. Not everyone's visual, right? You might look at this and guess wrong and put your center line down here. Like that's a little extreme, right? But maybe, maybe someone's put the center line down here, which is not so far off, but it's still, not the center. So we talked about how to find some of these things, like the amplitude. How do you get it? Well, here's the distance from a minimum to a maximum. Yeah, and this is 6 units. So I know my amplitude is going to be a maximum, subtract a minimum, divide by 2. In this case, it's 2 minus negative 4 over 2. 6 divided by 2, which is 3. So you might not look at that and realize the amplitude is 3, but you're going to as we put the pieces together. Okay, the center is a little more obvious because how do you find the middle of something? If you have 2 things and you want the middle, here's how you get it. You add them together and divide by 2. That sticks you right in the middle of them. So I know that my maximum is 2 and that my minimum is negative 4. So when I add them together, I get negative 2. Divided by 2 is negative 1. So here's my center line. Here's the amplitude we already calculated. Okay, so those are really handy for you to find the amplitude in the center line. Let's be specific about how we find the period. The period in this graph, you can think of it a few ways. Number 1 is it's the distance, so we'll call it the x distance, from a minimum to a minimum, because that represents one complete cycle, or a maximum to a maximum. For example, from a maximum to a maximum. That is one cycle. In this graph then, that distance from a maximum to a maximum, it still works minimum to minimum, but that distance is going to be pi in our graph. There's another way to think about this too. This one's not as obvious, but if I go from a minimum to a maximum, how much of the cycle is that? Yeah, it's half. It's not obvious until you kind of think about it, but if I start at the bottom and I go up, or same thing if I go from the top down, I've only taken half of it. So we could also call it the x distance 2 times the x distance. When we go from a minimum to a maximum, or vice versa. So the only thing that's left is that part of how do we then calculate a phase shift. And again, it depends on your point of view. Are you looking at it as a sine graph or a cosine graph, a negative sine, a negative cos? Let's stick with the ones we're most familiar with right now, which is sine and cosine. So I'm going to label some points. I'm going to ask you, let's call this point number 1. Call this point number 2, 3, 4. These are key points, right? So if I was to say, let's work on the sine graph, what number would correspond to the beginning of a sine graph? There's more than one up there. 6 corresponds to the beginning of a sine graph. That's correct. Any other numbers correspond to a sine graph? Yeah, 2 right there. So you could use either, which is going to give you 2 different equations, right? As long as you pick one of those, it's going to work. And then if we do this from the point of view of a cosine, what could you come up with for what numbers correspond with the beginning of a cosine graph? 3 and 7, yeah, right up here. That's the beginning of cosine there and there. So I'll just update so I'll call that phase shift. I'll pick this one here, which is pi over 4 to the right for sine. And I will pick the other one up here, which is, let's see here, number 7. That represents pi over 2. If I'm going to do the cosine. Okay. So if I take all those pieces and start putting it together, y equals the sine, y equals 3 times the sine of x minus pi over 4, and my center line is -1. I still have to figure out what goes in the horizontal stretch. Okay. Well, period is normally 2 pi over b, so b in this case, 2 pi over pi, it's going to be 2. Okay. So for the last graph, the equation will be for cosine. It'll have all the same things except the phase shift is pi over 2 to the right. Okay. So again, the way you do the phase shift, the period is 2 pi over b, and b is the number I'm looking for to put in my equation. So if I rearrange it, that means b is 2 pi over the period, which in our case is 2 pi over pi, which is 2. It's going to be the same period for the sine and the cosine graph. It's the same picture. It doesn't change just because you change the equation. Okay, so those are 2 possible answers. You could have a different phase shift, but everything else should be the same.